A falling stone takes 0.31 seconds to cover this 2.2 meter, and this question is about the uniformly accelerated motion in which you know that acceleration due to gravity is negative g. For Earth, it's negative 9.8 meter per second square. So in this question, you have to find out from what height above the top of the window the stone fall. Okay, so first of all, we should set the reference position. Okay, so imagine if it is dropped from this point, the stone is dropped from this point, so we will consider this position as the origin where the initial position of the stone is 0. So this is our x-axis, whereas this is our y-axis. So at this point, when the stone was released, we can consider y0 is initial velocity is 0 meter per second. So the stone covered this distance, that is y1. Let us consider this. And in this question, we need to find out this value. Okay, whereas I would say that this distance from the initial point to the final point, at this point, let's consider it y2. So if you want to find out the height above the top, so we are given acceleration, we are given the initial velocity, as well as we do not know, well, we do not know about this velocity at this point, that what was a velocity at this point, let's call it vy1. We also don't know about that. So let's apply any one of the kinematics equation, because this is the uniformly accelerated motion. And since you know we are not given the time to cover this path, that's why the most suitable equation is this one, vy1 square final velocity is equals to the initial velocity plus 2a phi delta phi. So this is 0 because it started from rest, whereas vy1 square is equals to 2 into negative g, whereas this delta y, now displacement covered from the origin to this point is negative, and you can see here 0, I mean the final position is y1 minus initial position is 0, but since the displacement direction is downward, that's why I can write here negative sign. Okay, now this negative sign and the other negative sign will cancel out with each other, and you can also write 2gy1. Okay, so we made an equation for y1, that is vy1 square over 2g. Okay, so let's see again what is a vy1. Vy1 is a velocity when it just passed from this level. Okay, the velocity at this point, and we don't know about that. So if you find out this velocity, you can find out also from what height we have released the stone. Okay, now to find out this velocity, we will use this data and this time to find out this velocity. Okay, now remember that you also don't know about this velocity vy2. Okay, so we will avoid now this equation because we don't know this velocity as well as the this velocity. So we should use such an equation which is none other than this one, initial velocity. Now in our this equation, vy1 is clearly an initial velocity. Okay, and time t is 0.231 plus 1 over 2 a y t square. Okay, now what is the displacement covered here? In this case, the displacement covered from this point to this point, as you can see, is 2.2 meter, but due to the direction, it should be negative 2.2 meter. And you can see that if I even put the value, right, so it should be y2 minus negative y2, because the displacement is downward, into negative y1. Okay, so this is the final position and this is the initial position, and when I will open the parenthesis plus y1, so our answer will be still negative. Okay, that's why I'm substituting here a negative 2.2 meter. is equals to, what is a Vy1? That's what we want to find out, into 0.31 plus 1 over 2 into negative 9.8 into 0.31 square. So we got an algebraic equation 0.31 Vy1, in which this Vy1 is a variable that we want to find out, and then the minus 0.470. So you can take this thing to the other side. So this is negative 1.73 is equal to 0.31 V51, and Vy1 is equal to negative 1.73 over 0.31. So you can also see that your answer will be a negative value, showing us a negative answer at this point because the velocity is downward. So negative 5.58 meter per second at this point. Now we will plug this value where, of course, here in this equation 1. So negative 5.58 whole square divided by 2 into 9.81. Okay, so finally our answer is 1.59 meter. So this is a distance above the window from where the stone was dropped, and then you can see how we have solved it.